Here's a really great question from homework number 13. It says, in a clinical trial of a drug used to help subjects stop smoking, 883 subjects were treated with 1 milligram doses of the drug. That group consisted of 47 subjects who experienced headaches. So 47 people out of the 883, after using the drugs, experienced nausea. They were nauseous. So we're trying to determine, the question is, really is nausea, oops, pen is being funky, is nausea a side effect of the drug? And this is important. You know, we talk about prescription drugs and their side effects. You hear them in the commercials and things like that. So how do you determine if nausea is actually a side effect of the drug, or if this is just what would happen under normal circumstances? And that's exactly what we are going to do. We take a look at what is the probability that somebody would experience nausea if they weren't on the drug. What is it under normal circumstances? And so that's actually how we test things. We don't test the drug, we test actually what we call the control group. And in the control group, the people not getting the drug, the probability of being nauseous for subjects not receiving the treatment was 0.0148. So we're down here, we're going to look at people not taking the drug, not on drug. Okay. Then we know that P, which in this case is going to be the probability of nausea. Nausea not on the drug, of the control group. Okay. And in this case, we are told it is 0.0148. Therefore, we can conclude that Q is the probability of not being nauseous, not on the drug. And Q and P are always complements, so we just jot it over here. P plus Q is always equal to 1. So if we know the value of P, we can find the value of Q, which will be 1 minus 0.0148. And if you just do that on your calculator, you will discover that Q, which is the probability of not being nauseous, is 0.9852. Okay. And to make things consistent, we will look at a group of 883 people not on the drug. So we have to have our control group and our experimental group, the group that's on the drug, they have to be the same numbers. All right, so let's find the mean value. What would be the expected number of people to experience nausea just naturally in the world without being on a drug out of a group of 883 people? Well, we know the mean is equal to n times p, all right? So in this case, n is 800. We're going to look at 883 people not on a drug, and under normal circumstances, 0.0148 people will experience nausea just naturally. And if I do that on my calculator, 883 times 0.0148, it's going to equal just about 13 people. Okay, and you can look at the question to find out where you're supposed to round. It's either 13 or 13.1. So 13 people not on drugs, just normal expectation would be 13 people out of 883 would get some nausea. Hope everyone knows what nausea is. It's a feeling like you're going to throw up, and I keep spelling it wrong, but that's what you could expect. All right. Now let's go ahead and figure out our standard deviation, because really the mean alone doesn't have any significance to us without some sort of understanding of the spread. Where do things become unusual? So in this case, if you remember, the formula for the standard deviation is the square root of n times p times q. So in this case, we need to find the square root of 883 times our 0.0148, times that Q value, which is 0.9852. Remember to multiply all of this together and then click on your square root button. And what you will get is 3.6 people. All right, that's our standard deviation. Okay, so what I'm going to do here, because we're kind of running out of room, is I'm going to add another layer here, and I'm going to actually move to the next screen. Let's clear this layer and actually leave that layer open. We'll clear this layer. And let's just jot down our mean was 13. And our standard deviation was, what was that again? 3.6. 3.6 people. Okay. Oops. All right, equals 3.6. All right. So what I'm going to do now is I'm going to draw a normal distribution curve because we want to find out if this 47 up here is unusual. Okay, so just a quick standard deviation curve, normal distribution curve, I should say. In a normal distribution curve, we have our mean of 13 people with nausea. X is going to equal the number of people with nausea. Again, this is out of a set of 800, out of 883. Okay, and we would expect a mean of 13 people with a standard deviation of 3.6. So let's find our maximum and our minimum values. We know our maximum value is where z equals 2. This is our z-score here. That never changes regardless of the problem. And we have a z-score over here of -2. Okay, so what are the, that's a 2, not a z, 2. Okay, what is this value and what is this value? All right, well, we know this is 2 standard deviations away, so it's going to be 2 times our 3.6, which is 1 standard deviation for this particular problem. So what is 13 plus 2 standard deviations of 3.6? That is going to equal 20.2. Right, 20.2. So we know right here that for 47 people, let's go back up here to this one. I'll pick a different color now. Back up here, 47 subjects experienced nausea when they were taking the drug. Where is 47 people? It's way, way, way out here. 47 is way out here, 47 people with nausea. That is so far above. That is so far, that is extremely unusual. In fact, we could find this z-score if we wanted to. Z equals the 47 minus 13 divided by the standard deviation of 3.6. If you remember, to find a z-score, it is equal to x minus the mean over the standard deviation. I'm just doing this. We know it's unusual. I'm curious how far above this, how many standard deviations 47 people would be. So 47 minus the 13 divided by 3.6 is equal to 9.4. We are 9.4 standard deviations above the mean if 47 people have nausea. So in the end, if this drug, people who took the drug, 47 of them experienced nausea, I think we can draw the conclusion that nausea is definitely a side effect of the drug, okay? Because is a side effect. Nausea is a side effect because getting 47 people to have nausea just under normal circumstances is so unusual. It's 9.4 standard deviations above the mean, that would just be so unlikely to happen. So if it happened in this case, I think we can draw the conclusion that the drug is playing some part in that. Give that problem a problem. That is a try. This is when statistics is really fun because we see how it's applicable in actual studies.